Yeah, welcome you all. Let's see problem number 5 today. Everybody take down this problem number 5. It's a sinusoidal function. Okay, so for the first time we are coming across a sinusoidal function. Find the Laplace transform of f of t. Okay, what is f of t? F of t is this. Everybody copy it down. Okay, so the given f of t is this. Okay, which looks like this. Okay, what is it? 0, 1, 2, 3, like this. Okay, and the amplitude of this is 1. So it is just this. F of t is given to be just this. Okay, it's now if you just observe this, it is a part of sine signal or cosine signal. You should be able to say. Everybody see here. This is the part given. Okay, now how to get the expression for this is what one needs to look at. Okay, how to obtain the expression for this is what one needs to look at. Fine. Now everybody see here in the solution. First, let's discuss whether it is sinusoidal or sine or cos. Okay, see here everybody. So if you all know that if the signal is like this, okay, then it is sine. Fine. Then if the signal is like this, then it is cos. Okay. So these are all t's. Get that point? Now we will just observe. This will just keep repeating. Okay, it will not stop with one cycle. Okay, suppose this is 0, 1, 2, then it is sine pi t. If in the if in the time axis, if it is written as 1, 2, then it is sine pi t. Understand that? So in that sense, so this would be 0, 1, 2. Okay, so it just goes on and on. It would be cos pi t. Now see the difference. I'll tell you now. Suppose suppose I have a sinusoidal signal. Okay, I have a sinusoidal signal like this. Fine. Instead of writing 1, 2, I'll write pi, 2 pi, 3 pi, and things like this. Okay, in the time axis, if it is pi, 2 pi, then the signal is sine t. If it is 1, 2, 3 in time axis, then it is sine pi t. If pi, 2 pi are there in time axis, it is just t. Okay, sine t. If it is 1, 2, 3, it is sine pi t. So this you just remember. Okay, now they have written it as 1, 2, 3. Now this is a part of which signal among these three? Everybody should understand this. Okay, let us write this also. Okay, you have another form of sinusoidal signal, that is cosine signal. Okay, which would look like this. Fine. If it is 0, pi, 2 pi, okay, and if this is t, this would be cos t. Which among these four has this part is the question. Okay, considering which among these, okay, you can build this given f of t is the question. Okay, so that is how we need to think. See here, now see the time axis. Time axis is 0, 1, 2, 3, right? Okay, so that means, so these two are gone now. We cannot talk in terms of sine t and cos t. So if you have to talk, we have to talk in terms of sine pi t and cos pi t. And since it is 0 at t equal to 0, it is sine pi t, not cos pi t. So this is what we have to use to get this. Everybody is okay with that? So how to construct this? There are multiple ways again. Okay, so let's construct, everybody. Let's construct f of t now. So for that, what we shall consider? So for that, what we shall consider? We shall consider sine pi t. Okay, everybody write the sine pi t signal there. Let's write sine pi t signal and let's name it as f1 of t. Okay, so let's just take this now. Okay, I'll call it as f1 of t. Okay, let's do this. Fine. So I want a signal which is this. Okay. Now since this is 0, 1, I have to write 0, 1, 2, 3 like this. Okay, so let us bring this further. Let's just extend this time axis. Okay, this is how it will keep doing. Fine. So we have f1 of t. Now I need to retain only this part. Everybody understand? I need to retain only this part. So what I can do, see this, how beautifully things go if you think a bit. Okay. So let's consider another signal f2 of t. Okay. And in this signal, what we shall have? What we shall have is this. See here? You see this? See what I'm going to do now with this. In this part, I'll let the signal to start after a delay of 1 second. Okay, so this is f1 of t starting at 0. This is f2 of t starting at 1. Everybody understand that? Okay, so the one signal is starting at 0. The other sign is starting at 1. Fine. So what can we do to retain only this part? Now see here, this is positive, this is negative. This is positive, this is negative, positive, negative. So if you add these two signal, okay, the signal would vanish from t equal to 1 onwards. Okay. So beyond t equal to 1, the things will go 0. So therefore, f of t, okay, can be written as what? F of t, let me give you another okay, so suppose if we do f1 of t plus f2 of t, what would be remaining here? What would remain is the question. See here, from 0 to 1 it is this signal plus 0. Okay, so you would have the same signal here. Fine. Now from 1 to 2, from 0 to 1, this is what is going to happen. From 1 to 2, what's happening? The same signal. This is minus 1. This is plus 1. Okay. This is plus 1. This is minus 1. Minus 1, plus 1. So that means the inverted signals are there and you're adding them. So what would happen? So whole signal beyond that would go 0. Understand that? So this is how the signal is going to look like. Fine. So this is your what? This is your f1 of t. Get that point? So this is your f1 of t. Let me write this is 1 and this is minus 1. This is 1 and this is minus 1. So what would remain is a sinusoidal is this sinusoidal function of amplitude 1 from 0 to 1. So this is how we can construct the given f of t. Okay, so therefore we can say therefore we can say f of t is actually f1 of t plus f2 of t. What is f1 of t? Okay, as we have understood here, you need not have to write all this in the exam if it is asked. Okay, this is just for your reference. So which signal is f1 of t? F1 of t is sine pi t. If this is sine pi t, what is the shifted version of sine pi t? So this is shifted by 1 second, right? Okay, so how would you write that? If f1 of t is sine pi t, okay, what would be f2 of t? F2 of t would be sine pi t minus 1. Why it is shifted in time, isn't it? So that's why we need to represent f2 of t like this. See here, it is shifted by 1 second onto the right. If it is onto the right, it is minus 1. Is everybody okay with this? Fine. Now, what is sine pi t? We know that we know that by standard transform, okay, Laplace transform of, okay, sine omega naught t is what? Is omega naught by omega naught square plus s square. Call this as equation number 1. Okay, let this be f of t. Fine. So, and also by what? Time shift property. Time shift property. What is known? What is known? Sine. Sorry, if you take x of t minus t naught, okay, and if you apply Laplace transform on this shifted signal, okay, so it would be e power minus t naught s into x of s. Okay, so therefore applying Laplace transform on 1 implies what? If you apply Laplace transform on f of t, it is f of s. Okay, sine pi t is there. What is the Laplace transform of sine pi t? See here, sine omega naught t is a Laplace transform is known. So in place of omega naught, you have pi. So it is pi by pi square plus s square. Okay, then plus. Okay, if what is the basic signal? X of t is the basic signal. Okay, x of s is the Laplace transform of x of t. So what is basic signal? Is sine pi t is basic signal, and since it is shifted by 1, you will have e power minus s. So it is e power minus s into pi by pi square plus s square. Okay, so which is the common term here? So therefore f of s can be written as, take this out, the common term, and what is left inside is 1 plus e power minus s. So this is what is the f of s asked. Okay, f of t was given and they have asked us to obtain f of s. So this is how we can obtain f of s. There is another method in which you can do, okay, as we were used to. You can consider f1 of t, okay, and then you can do this. See, alternately you can just try this. It would be a good exercise to you. Okay, alternately Alternative, what we can do is, see here, everybody, let's again consider f1 of t, okay, and that is, is the sine signal, okay. Let's write it like this. We'll just go on and on and on. And what is this? 0, 1, 2, 3, 4. So this is our f1 of t. Let's take f1 of t the same. Okay. But instead of taking the shifted version of f1 of t as f2 of t, we can even do this. What is that? What is that? We were doing some multiplication operation, right? So what we used to consider in that case? We used to consider something like this. Remember that? So this is the signal from 0 to 1. So if I consider this as f2 of t, what operation you would perform on f1 of t and f2 of t so that you would obtain f of t is the question. See here, this is 1 now. So which operation you would perform? If you perform f1 of t into f2 of t, you would tend to get the given signal. Okay, that is this. Okay, so this is another way of dealing with it. So you can try get that f of t in this form also. Therefore what? F of t is actually f1 of t into f2 of t. Whereas in the first method, we had considered two signals, and with those two signals, we had to add the two signals to get the given f of t. But here, with the f2 of t considered, we need to multiply the two signals to get the given f of t. So what is f1 of t? As you have seen in method 1, f1 of t is sine pi t. What is f2 of t? F2 of t is a rectangular function, and we know rectangular function can be constructed using the unit step functions. Okay, so this is what is this. Okay, do this yourselves, alternate method. Okay, and try get the same f of s. Fine, you already know the answer. The answer should be this. Maybe you'll get the answer in different form, but you should try get compare the two and see that both happen to be the same. Fine. Now this is regarding the finite time signals. Now see, what we'll do is we will take the sinusoidal, or we shall take the periodic signals. Okay, the periodic signals are what? Periodic signals are repetitive in nature. So if you are given a signal which is repetitive in nature, how would you deal with it? Okay, so everybody take the heading as Laplace transforms of periodic signals. Laplace transform of periodic signals. Here 80% of the solution is similar to what we have been doing till now. Okay, but it would just have the extended solution there beyond. Get that point? Now let's see this. Everybody take down this. Let's take this as problem number 1, since we are taking the periodic signals. Fine. So the question is, find the Laplace transform of f of t. But here in this case, f of t would be a periodic signal, which is repetitive in nature. So which signal they are giving? Let's understand this. See here. Suppose they would ask us the See here. Now let's take this. I'll tell you how the things get easier. So this is what is the signal, and this keeps repeating, mind you. The periodic signal means it should keep repeating for infinite number of times, otherwise it's not periodic. Okay. Now, so this is f of t. Okay. 0, 1, 2, 3, just it goes on and on and on. Okay. The amplitude of this is 1. So this is the signal. Now you have, which is repetitive pattern, you have to just consider the repetitive pattern. Which is the repetitive pattern? Repetitive pattern is this. 0 to 1 is there is a pattern from 0 to 1, and that pattern is repeating after the same duration. Okay, so after that particular duration, the same pattern would keep repeating for infinite number of times. So what is the fundamental period here? What is the fundamental period? What is the meaning of fundamental period? Fundamental period is one, is a duration after which there's a pattern repeating itself. So after what duration here the pattern is repeating itself for infinite number of times? After every 1 second the pattern is repeating. See, after every 1 second the pattern is repeating. Understand? So every periodic signal will have the fundamental period. Okay, and that fundamental period is the duration after which the patterns are repeating. Is that okay with you? Fine. Now if such a signal is given, okay, if such a signal is given, what would you do is the question. See here. So what you would do is you have to just consider the part which is repeating. Consider the part which is repeating. Okay, call that as f1 of t. So this is what I'm giving you the procedure. Step 1. Step 1. What is step 2? Find Laplace transform of f1 of t. F of t is given. Okay, so we're just considering the part of it which is repeating, and we are calling it as f1 of t. We apply the Laplace transform on f1 of t, that is the repetitive part. Okay, that is what, if we apply Laplace transform f1 of t, we'll be obtaining f1 of s. Step 2. What is step 3? Therefore f of s. What is that? Laplace transform the given signal. Therefore Laplace transform of f of t is what? F of s, and that f of s is what? That f of s is, see here everybody, f1 of s divided by, okay, 1 minus e power minus ts, okay, where t is the fundamental period. So these three steps you need to follow. Okay, so let's go with the solution now. Everybody, just see here. So let's have this as the procedure of obtaining the Laplace transform of the signal which is repetitive in nature. This is the procedure. So what we shall do in this solution, we shall consider the part which is repeating. So let's call that as f1 of t. Understand that in the solution. Everybody just copy it down. Just copy it down, everybody. Consider the repeating part. Okay, so what is that repeating part? That repeating part is this. Okay, 0, 1. Fine. This is 1, and let's call it as f1 of t because that is what is there in this procedure. Okay, and you should know the fundamental period. Let's take that later on. Okay, so you have to find the Laplace transform of this. So have you seen this part earlier? Yes, see here in the last problem that we have solved. Okay, so we have obtained the Laplace transform of this particular signal which we have considered now. Here this is the signal which we have considered. Okay, so since I already have obtained the Laplace transform of this, okay, I'll just be copying it from, so this is problem number 5, right? Refer to problem number 5, I'll say. Okay, so what we have done is we've obtained the Laplace transform. We have to obtain it ourselves in the exam since we have done it. Okay, so you have to do it yourself. Fine. So f1 of s is given by, yeah, so we have seen this and we have done this already. F1 of s would be, what would that be? It would be pi by s square plus pi square into 1 minus e power minus s is f1 of s. Okay, so refer problem 5 here. So the previous problem only, so you should not have problems coming to this. Okay, so therefore Laplace transform of f of t is given by what? It is given by f of s equal to what is the see, this is the equation we need to consider. F1 of s divided by f1 of s divided by 1 minus e power minus t. Yes. Okay. Uh, since uh, let's write here. Since f of t is repeating after every 1 second, okay, fundamental period t is equal to 1 second. So that is what is this. Okay, so therefore what is f of s? Therefore f of s is given by, what is f1 of s? F1 of, let's write this, 1 minus 1 minus, okay, since t is 1 it would be e power minus s. Okay, then what is f1 of s? F1 of s would be this. So let's write that. So what is that? It's pi by pi square plus s square into 1 minus this. So this is what is f of s. So for that, what is that we've considered just the repetitive part. Find the Laplace transform of the repetitive part. If you have the Laplace transform of the repetitive part, then the Laplace transform of the whole signal, which is repetitive in nature, can be given by this equation. Okay, so that is why we can write the f of s as this. Is this understood, everybody? So let's take another problem of this sort. Let's take another problem. What is that? Everybody just copy this. Problem number 2 in periodic signals. Fine. Find the Laplace transform of f of t. F of t is given here. Everybody copy this. It's given as this. Should be repetitive in nature. That is when it would become periodic. And it should be repeating after the same number of seconds, after the same duration. Okay. And this would keep happening. Fine. So it is repeating after, see here. So this is t. This is f of t. Fine. And this is 2. Now, what would you do with this? What would you do with this? This is the problem. Very similar to what we have done in the previous case. Same procedure needs to be followed, but you need to consider the part which is repeating itself. Okay, so what is that in the solution? Consider what? See here, everybody. Consider only this. Fine. What is this? This is f1 of t. Let's call it as f1 of t. The given signal is f of t, which is repeating signal, periodic signal. But let's just consider the part which is repeating. Okay. So just consider the part which is repeating. Okay. This is 0. This is 2. So how would you construct this signal is the question. And obtain, how do you express this mathematically and obtain the Laplace transform of f1 of t? So how can we do that? To express now. To express f1 of t mathematically, consider what we need to consider is what I'm telling you. See here, I need to consider a signal which is like this. Everybody okay with this? This is 0. At 1, it is 1. Okay. At 2, it is 2. So this is, let me call, which uh, signal is this? Can you identify this? Anybody would like to comment on that? Which signal is this? This is what? Ramp signal. Ramp of amplitude, sorry, slope 1. Slope is 1. Since slope is equal to 1, this ramp can be called as t. At 1 it is 1, at 2 it is 2. At t equal to 1 it is 1, at t equal to 2 it is 2, at t equal to 3 it would be 3. So this signal is t. Everybody understand? So this signal is t. So but I want this signal from where to where? I want this signal from 0 to 2. So what would I do? So what would I do? I would do this. I would rather consider a signal which is 1 from 0 to 2. Yes. Now what I'll do? So this is what I have: 0, 1, 2. So which signal is this? This is u of t minus u of t minus 2. So what way you can express f1 of t in terms of these two? We have done that before. Okay, I'm just doing it again. Therefore, f of t, f1 of t rather, is obtained by multiplying t by u of t minus u of t minus 2. Okay, so if you multiply, how would it look like? It would look like t, sorry, into u of t minus t into u of t minus 2. This is valid form, this is invalid form. So what we would do, we'll keep this as it is. To get this into valid form, I'll do minus 2 plus 2, okay, into u of t minus 2. Expand this, expand this, okay, that is tu of t minus t minus 2 times u of t minus 2, okay, plus no, it's again minus, right? So because minus is here, it's again minus minus what? 2 u of t minus 2, f1 of t. Therefore Laplace transform implies what? Okay, you see that and get me f1 of s. And once you get f1 of s, therefore f of s would be what? f1 of s divided by 1 minus e power minus ts, okay, where t is equal to what? 2 seconds. T is equal to 2 seconds. Why? Because it is repeating after every 2 seconds. So the fundamental period is 2. Okay. And f1 of s you can obtain by applying Laplace transform. Substitute that f1 of s here and write f of s. Okay. So that is what is going to be the answer for this. Fine.